All right, here we go. So what we're doing today, we're going to go over some of these questions here. Hopefully it'll help you out with the homework. Um, on all of these evaluating, right, we're trying to figure out which equation to plug in x for. Now these are our x values. We'll do them one at a time. You just have to figure out, do you plug it into that top equation or the bottom equation? And that's where the restrictions come into play. So I'm just going to put our work off to the side here. So for f of 0, right, we're going to evaluate that. We're plugging in 0 for x. So we look up here, right? Look at the restrictions. You ask yourself the question, is 0 less than 1? Yeah, 0 is less than 1, right? On a number line, here's 0, here's 1. 0 is to the left of 1 or less than 1, so we're going to plug it into that first equation. Right, so we're going to take 0, plug it in. That's 0 squared minus 3. 0 squared is 0. 0 minus 3 is negative 3. Finishing off that first question for us, so what we're going to get is f of 0 equals negative 3, or write it as a coordinate point, 0, negative 3. Okay, I'm just going to erase this because we're going to use it again. So now we look at b. Sorry, let's put the answer in there, negative 3. For b, f of negative 2. Again, we're plugging in negative 2 for x now. So you go up here, you ask yourself this question, is negative 2 less than 1? Yeah, it is, right? Just like we can use the same number line, 1's still here. If we finish out the number line, get to negative 2, negative 2 is still to the left of 1. It's still less than, so we're still going to plug it into that first equation. So what we do, plug it in for x, negative 2 squared minus 3. Negative 2 squared is 4. 4 minus 3 is 1. So that ends up giving us the function of f of negative 2 equals 1. Or, again, you can write it as a coordinate point, negative 2, comma 1. Which finishes off part B for us, right? So f of negative 2 was 1. Now again, I'm going to erase this. We're going to use it again, right? We're just going to keep using these equations to figure out which one we use. I'll leave the number line because that'll stay the same. C. Now we're doing f of 2. Again, ask yourself that question. I'm always starting with the top just because it's on the top, right? Is 2 less than 1? No, right? Because if we put 2, 2 is greater than 1. I know that's like an obvious question. 2 isn't less than 1. So we don't plug it into the top one in this case. We go down here, is 2 greater than or equal to 1? Yeah, it is. So we're going to plug it into that second equation. We plug in 2, that's negative 2 times 2 plus 1. Negative 2 times 2 is negative 4, plus 1 is negative 3, giving us f of 2 equals negative 3, or that coordinate point 2, negative 3. Okay, so again, you can write it in either of those fashions. Eventually we need to make the relationship in our head that f of 2 equals negative 3 is the same thing as a coordinate point, which we'll get to in another unit. I'm just trying to get you there. We move on to the fourth one. Again, let me erase some of this stuff so we can go back and use it. Now we're doing f of 1. Plug it in 1 for x, you check. Is 1 less than 1? No, right? 1 can't be less than itself. You go down here, is 1 greater than or equal to 1? Yeah, it is. So we plug it into that second one again. So again, we're going to go negative 2 times 1 plus 1. Negative 2 times 1 is negative 2 plus 1 equals negative 1. That finishes that one off for us, giving us that f of 1 equals negative 1. Or, again, you can write it as that coordinate point 1, negative 1. And then to finish it off, part E. Oops, let me put the answer up here. F of negative 1. Right, so we're looking at negative 1 now. Again, let me erase some of this stuff because we're going to use those equations one last time. F of negative 1, we look, is negative 1 less than 1? Yeah, look, negative 1's to the left of 1 over here. So it's less than 1. Check. We plug it into the top one. You don't even have to check the bottom one, right? Negative 1 can't be greater than 1. Plug it into that top one. Again, just be careful there, right? Plug in negative 1, negative 1 squared minus 3. Negative 1 squared is positive 1. Minus 3 is negative 2. Okay, giving us f of negative 1 equals negative 2. Or the coordinate point, one last time, negative 1 comma negative 2. That will finish off that first question for us. I don't think I'm going to go through the second question just because same exact process. Make sure you all are taking your time there. I think you can handle that one. Okay. All right. So here we go on the second question here that I was going to look at. This is our piecewise graphing. So this was a bulk of our lesson that we did in class. Piecewise graphing is just doing two domain restricted graphs. So I'm going to go through that process twice here and show you all what happens. So the first thing is just label each graph. Right? We have two pieces here. Sometimes it's two pieces, sometimes it's three pieces. It kind of just depends. And I'm going to take that piece off to the side. So we have f of x equals, I'm just writing that top line, x squared if x is greater than 1. And what we're going to do now is just graph this, right? We're graphing this piecewise equation. This is going through those steps that we have for graphing. So you look at it, the first thing is that squared is telling us that it's quadratic, so we know it's going to be a u. The second thing is where's that vertex. So again, when we're finding the vertex, we look at what's added on to the equation. In this case, there's nothing added on, right? There's no plus 3, there's no like x plus 2 in parentheses squared, which means there is no translation there for our quadratic, telling us that our vertex is 0, 0. I'm going to put no translation. After we get that, let's add it on to the graph, right? So 0, 0, there's our vertex. Next part, right, as we're doing these domain restricted graphs, we get that vertex. Before we actually do the graph, we're going to apply this restriction. So this restriction is happening at 1. I'm going to draw our line here for our restriction at 1. Okay. After we do that, there's a couple things that the restriction tells us. First, we look at the restriction specifically. It's a greater than. What that's telling us is we're going to be graphing to the right of 1. So where 1 is, our graph is going to be on the right side, which is interesting because our vertex is already on the wrong side. But that's okay. The second thing that it tells us, because it is just greater than, right? That's telling us that it's going to be an open point. So when we get the point on the restriction, it's going to be open. After that, we can actually go through the steps of graphing here, right? For quadratics, we can't use a slope. We have to use the table. So we set up the table. We always start with that vertex in there. That's at 0, 0. That's done. Now to find the next piece on the graph, we're always going to plug in this restricted value. Since we're restricted at 1, we're going to plug in 1 into the table. Okay? It's because that's the restricted value. Excuse me. After that, plug it in. Again, we're just plugging it into this equation right here. 1 squared is 1, giving us the coordinate point 1, 1, which now we can slap onto the graph there. Right, 1 up 1. Anytime you're putting a graph on the restricted line, start with it nice, wide, and open. We check down. It's supposed to be open, so keep it open. And we could actually finish our graph. Now, this is quadratic. This is what it would look like. Right, since there's that point up 1, right 1, there's 1 up 1, left 1. If we were just graphing, don't do this, that's what your graph would look like, right? It's quadratic, but we're restricting the domain. We don't graph the whole thing. We're only graphing to the right of that green piece there. So really, all we want is this right piece, and even what I have there is wrong because we still have the vertex on the left side. So all we actually want for this quadratic graph is just this piece here, right? We're just using the vertex to show us how steep that has to be. The vertex is even on the wrong side, so we got to get rid of that. Now we have our quadratic. It's only graphed to the right side of 1. So sometimes you do have to eliminate that vertex, which is fine. We're going to move on to step 2 now. Okay. Step 2, I'm just going to rewrite that equation. This is the second piece. If x is less than or equal to 1. And you'll start noticing some things quicker. You can go in whatever order you want. I just like to try to use the same steps that we use. First step, identify squared, quadratic, right? Quick, that's a U. Second step, nothing added on, just like that original, or just like that first equation. So a vertex, sorry about that, is 0, 0. We can put that on our graph. Oops, sorry, pressing a button here, so it's kind of messing up with me. There we go, there's our vertex. For this quadratic, we look at the restriction. Now it's still at 1, so we're still using that same restriction line, but in this case it's a less than or equal to, saying we're graphing to the left, so this graph is going to be on the left side. And because it has the or equal to, that's telling us when we get to the restriction line, it's going to be filled in. Okay, so we're graphing to the left. When we get to the restricted line, it's going to be filled in. We know it's quadratic because it's squared. To finish it off, we use the table. And again, start with the vertex. The vertex happens to be the same. Plug in the restricted value. The restricted value, again, is 1. So we're plugging in 1, and this is where we have to be careful. We're plugging in 1 for x, right? So the negatives there, we're substituting in 1 for x. What the? 1 for x there. It's still squared. Now we do order of operations. 1 squared is 1. The negative's still out in front. So we get the coordinate point 1, negative 1. We can graph that. It's on the restricted line, so we're going to start with it nice, wide, and open. But we check it's supposed to be filled in, so we could actually fill in that point there. And again, if we were just graphing this, this is quadratic. That's the right side of your U. The left side looks the same. So that's what the left side will look like. But this isn't just a regular quadratic graph. It's domain restricted. We're only supposed to be on the left side. So make sure when you're drawing that right side of the graph, you only go up to that restricted value, right? Don't go past it, because now you'd be greater than 1. We only want less than or equal to, which is the or equal to tells us to fill it in. So that's your domain restricted graph. To finish it off, you do the domain and range. For domain, domain is x values, and ranges are y values. And there's something interesting that happens on this. So first, let's talk about domain. How far to the left does this graph go? You look at this blue quadratic, that's the left side. The farthest to the left it reaches is this arrow, which means infinity. That means it's going to the left to negative infinity there. Not going down, it is going down, but it's also going to the left. So now we start sliding. Slide, 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 slide. We're going to the right, we're going to the right, and then stop right here at the restriction. Something happens. We hit an open point at this value of x equals 1, but we also have a filled in point there. So we don't have to stop our interval at 1. We're just going to go past it, keep going, and the farthest to the right we're going to get is this value here, which is another arrow telling us the domain goes to positive infinity. We did not have to stop our interval there. Okay. Now, for the range, bottom to top, look at how far down this graph goes. Now, this happens to be the same place, right? It goes down to negative infinity. And now we slide up, right? Slide up, 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 and then stop. Why do we have to stop there at 0, right? Now, we're stopping here at 0 because there's this gap, right? From this blue to the red graph, there's a gap there. So we have to stop our range. So how we stop is the highest this blue graph reaches is 0. At 0 it's filled in. That's a bracket. We can't make it go to 1 because there's nothing in between 0 and 1, so we have to stop our range. Now we restart our interval. In this case, we don't start back at 0, we start at 1. So we're going to start our range at 1. That's a parentheses, it's open, and it's going to go up to positive infinity. There's two intervals there. Connect them with the union. But that finishes off the range for us. Again, we had to stop the range because there's that gap between 0 and 1, so there has to be a gap in our interval as well. Okay, that finishes off that problem for you. I'll try to get through the rest of these problems. We'll just see how much time I got. Alright, so here we go with number 5. Again, domain restricted graphing, or sorry, piecewise graphing, which is really just 2 domain restricted graphs. That's why I usually say domain restricted graphing, because that's what we're doing. But again, I'm just going to start off by labeling our 2 pieces and just take it one piece at a time. Right, piecewise graphing. So I'm going to take that first piece and just work with it over here on the right. So we have f of x equals 3 to the x plus 1 if x is greater than or equal to -1. So the first step, again, is I identify what kind of graph it is. X is up here in your exponent, right? If x is in your exponent, that's telling us it's exponential, which is important because that means we go from 0, 1 for our translations. Be careful there, 0, 1. After that, we just figure out what's our translation. From that starting point of 0, 1, that x plus 1 right there is telling us to go to the left 1. So we're going to go left 1 from 0, 1. Okay, so I'm going to go to 0, 1. This is where we're starting. Don't put a point there. I'm just showing you where we're starting. 0, 1. We're going to go left 1. That's where the starting point actually is. Okay, we went left 1 from 0, 1. I'm going to draw on the asymptote right now, though we'll probably have to erase some of it because this is domain restricted graphing. The asymptote is always one step below that translated starting point. Okay, after you get that starting point down, now we look at what's the restriction. Okay, so look at that restricted value. That's happening at x is greater than or equal to -1. So it's happening at -1. I'm going to draw that restricted line at -1, which happens to be where that starting point is. Because that happened, you know what I should have done instead of just immediately filling in a point there? It's on a restricted line. Let's make sure we draw it as nice and open, because who knows, what if we had to keep it as an open point instead of fill it in, which we're going to find out right now. We look at the restriction. It's happening at -1. We just drew the line. It's greater than, which means we graph to the right. So we're graphing this one to the right side of -1. And because it has that or equal to right there, that means we're going to actually fill in the point. So I know I just opened it up. We are going to fill it in. One more thing we can do, if we're only graphing to the right side, let's get rid of the asymptote on the left-hand side as well. That's why I highly recommend you all are doing some of this in pencil, because sometimes we do have to make some changes there. Okay, to finish off this exponential graph, all we have to do is use the table. Now again, I always start with that starting point, that critical point that we have. That's at -1, +1. We already graphed it. Now usually we just go ahead and we take the restricted value, and that's what we plug into the table. Notice we already have -1 plugged in for x, so we're not going to do that. We're just going to go up 1, plug in 0 for x, and that'll give us a value here. So we're plugging in 0, 3 to the 0 plus 1. 0 plus 1 is 1. 3 to the first power is 3, giving us this coordinate point, 0, 3. Which is on the right side. We can graph it 0, 1, 2, 3. And that is going to be our exponential graph. Now really this is what it looks like, right? That's the entire exponential graph, but we only want this piece that's on the right hand side, which is why we're going to start at that restriction there and just shoot it up, right? It's just a little piece of our exponential graph. That's the first piece done. Now we can work with the second piece. Second piece, I'm just going to rewrite it. F of x equals -2, absolute value of x plus 2 plus 3 if x is less than -1. We look at it, when I'm reading that, it's important that you can read it, because when I was reading that, I said -2 absolute value, x plus 2. It's telling us what kind of graph it is. It has those absolute value bars. That means it's linear absolute value. Because it's linear absolute value, we're going back from 0, 0. We only go 0, 1 on those exponentials. For that translation, x plus 2 is telling us to go left 2, plus 3 is telling us to go up 3. So we're going to go left 2, up 3 from 0, 0. Left 2, up 1, 2, 3, and that puts us right here. Okay, that's our vertex. Again, the starting point for absolute values and for quadratics is the vertex. Now let's look at that restriction. Again, it's happening at -1. We already have the line drawn there at -1, so that's good. And it's telling us to graph where it's less than. Less than means we're graphing on the left side, right? It's an arrow pointing us in the left. So we're going to graph to the left there. And then the last thing, because it is just less than, it doesn't have the or equal to. That means when we get that point on the restricted line, it's going to be open. Okay, so we can finish this off. How we finish off linear absolute value graphs is we can use the slope, right? We can use the slope. We don't have to use a table here, though you can if you really want to. So we're just going to use the slope. The slope is that number sitting right in front of the absolute value. So in this case, it's a -2, which we would write as -2/1. Negative slope means that v should be opening down. Just keep that in mind. So we're going to rise -2 and then run 1. So you're going to go from your vertex, you're going to go down 1, 2, go to the right 1, and look what happens. We end up right where that other graph starts off. That does not happen every single time, just very certain cases, and they happen to love to do those cases on the homework. So we draw that point. It's supposed to be open, though it's already filled in. That's okay. That just counts as a filled in point. This is a linear absolute value graph. The right side looks like the left side, so since there's a point down to right 1, we can go down to left 1. That's going to give us our v. Right now, again, this is what your v would look like if we were just graphing the absolute value graph. But we can't have anything on the right side, so we got to get rid of that piece on the right side and really just only go up until that point right there. That finishes off our piecewise graph. And then to finish off the problem, we'll do domain and range. For our domain, farthest to the left it goes. This is the farthest left piece. It hits an arrow. That means it's -infinity. Slide to the right, stop at any open points. There are no open points. This right here is not an open point. It's been filled in. So you just keep going, keep going. You hit that arrow on the right, goes to +infinity. For our range, very similar. The farthest down it goes is again on this blue graph. Hits an arrow that's -infinity. We slide up, slide up. We don't have to stop there. That's not an open point. Keep going, keep going, keep going. Hits an arrow, -infinity to +infinity. So that's our domain and range there to finish off that problem. Alright, so we're going to go into some more piecewise graphing here. Again, it's just 2 domain restricted graphs. I'm going to start going through these a little bit quicker because I assume if you're at this point where you're working through these problems and you got through those first 2 problems, whether it was watching the videos or you were just able to get through them and you checked your answers, then you should be pretty proficient at this. So I'm not going to sit here and go through as long, just because we can get through these examples a little bit quicker, and I'll be able to get more out to y'all by doing it with a little more speed. Obviously, we're not going to go like rocket speed here, but you look at that, break it up into 2 pieces. Look at that first piece. Identify the function. There's no squared, there's no absolute value, there's no exponent, so it's linear. Because it's linear, we just need to find that starting point. That -1 there is telling us to go down 1. That -2 in front is the slope. Don't mess with it, not yet. We're just going to go down 1 from 0, 0, and that's where the starting point is. Okay, you get the starting point. Now we look at where's the restriction. The restriction is this piece at the end. It's happening at 3, so I'm going to draw that line at 3. Okay, check, that's at 3. Look at the restriction, it's less than, which means we're graphing to the left of that line, and because it's just a less than, it's going to be an open point when we get to the restriction. Alright, and we can finish off this graph. for lines, it's nice. We went down one. We can just use the slope now to finish it off. Slope's that number sitting in front, which in this case is -2. Write it as -2 over 1. That's our rise over our run. Okay, so you go from your starting point, just make sure you go all the way to the restriction, down to right 1, down to right 1, down to right 1. You get on that restriction, put it as a nice open point. We check, it's supposed to stay open. That's the graph of our line. And we're only graphing to the left here, so only graph that line on the left hand side. Hey, that was pretty good. That was pretty straight there. I'm pretty proud of myself. But that's the first piece of your restricted graph. Now we look at the second part. That's the second equation. F of x equals -x squared plus 10. That'll be fun. If x is greater than 3. So we look at it. It's quadratic. Sorry, it's quadratic because it's squared. So that means it's going to be a u. Let's find that starting point. The translation is up 10. Right? So we're going to go up 10. 1, 2, 3, 4, 5, 6, 7. Up 10 is going to be up here. I'm just going to put it, I know it's in a dramatic place. That's okay. We're going to say that's up 10. That's where the vertex is. It's a quadratic. That means it's a u. Let's look at what the restriction is. This is why I'm not too concerned about that vertex. The restriction is again at 3, but in this case, since it's greater than, we're graphing to the right. Right, so we get to this restriction at 3, and we're only graphing on the right-hand side for our quadratic graph, which is why I'm not too caught up with our vertex being over here, up here at 10, because that's on the left side. We're going to have to erase it eventually anyways. This is just going to show you all how steep it is. Our vertex is up there, way up there at 10. We need to finish off this graph. We know it's going to the right. It's just greater than, so it's going to be open when we get to that restriction. And to find the rest of the graph for quadratics, you have to use the table. Now the first thing is using the vertex. That's 0, 10. But the next step, again, we usually just go +1, plug that in. But in this case, for domain restricted graphing, always plug in that restriction. So there's the restriction at x equals 3. We're going to plug in 3 and watch what happens. So when we plug in 3, just make sure you're being careful. We go negative, put the 3 in parentheses, squared, because we have to do order of operations there. 3 squared is 9, so that means -9 plus 10, which is +1. So we get this point 3, 1. Okay, so we should graph that, 3, 1. We end up on our restriction, which is exactly what we want. Start with it noticeably open, check. It's supposed to be open, so leave it like that. Now this is the only reason we graph the vertex, right? It's on the left hand side. Look at what this quadratic is going to look like, right? If we were to graph it, this is the vertex up here. It's a u. Holy crap, that is a steep u. That's what it looks like. Now obviously I could have done a better job of drawing that, but that's essentially what our quadratic looks like. It's just a really steep drop off, and notice we're just going to take this part here, this piece on the right hand side, because we're graphing where it's to the right of the u. That's why we have the vertex there for right now. Okay, let me make it a little bit better. So again, it's just going to be this, like, gosh, I can't draw a nice curve here. It's just going to be that little piece right there popping off from the 10. That vertex up there, we got to get rid of it. That's on the left side. We only want that piece on the right hand side. That finishes off the graph for us. And then domain and range. So domain is our x values. Right here's the farthest to the left it goes. That's -infinity. Hits an arrow. So we slide to the right, and look at what happens here. Right, we get to 3. There's an open point at both of these. Since they're both open, you have to stop your interval there at 3. There's no x value graphed. Stop your interval at 3. That's an open point, parentheses. Now we start the interval back up at 3, because all we've done so far is say this for our domain. Now we start our interval back up at 3. We reach another arrow telling us that's going to go to +infinity. For our range, or y values, now we're looking at bottom to top. The lowest this graph reaches is right here on this red graph. That's down there at 1, 2, 3, 4, 5, 6, 7, -7. It's an open point. and then slide up, right? Slide up, slide up. Oh, you know what? I'm wrong, right? -7 looks like it's the lowest point, and that's the way we graphed it. But I'm glad I made this mistake. Look at our blue graph here, this quadratic. What happens? Right, that graph keeps going down forever. It even passes this lowest point here. So our lowest point on our range is actually -infinity, right? My bad. Now we slide up. We don't have to stop at this open point here because we have this graph. So we go past it. We have another open point here. We don't stop because same argument, that red graph's going to keep going up to positive infinity. And that's our range. Again, that's because that blue graph and that red graph, they shoot up forever. They overtake those open points. And that finishes off the domain and range. All right, so here we go again. We're doing another piecewise graph. First step, again, is just labeling the two pieces. And as I do more of these, I'm going to try to get a little more efficient with how fast I go through them. Just because if you made it to this point, you've probably watched either a few or you're very comfortable and you just need a little thing to be fixed. So I'm just writing that first piece. X is less than -2, and we'll get into it. Right, so for that first piece, it's quadratic. You need to be able to identify that. That's quick. As the squared, check. Quadratic, sorry about that. After you find out that it's quadratic, you look at what's the translation. This x is attached to the 3, so that's telling us to go left 3. That's when it's attached, right? We're going left 3 from 0, 0. Plot that point, there's your vertex. Okay. Now let's look at the restriction. The restriction is right here. It's saying x is less than -2. First thing, go to -2, draw that restricted line. Okay, that's at -2. For this graph specifically, we're graphing less than, which means we're graphing to the left of -2. And at -2, when we get there, because it's just less than, it's going to be an open point. All right, restriction done. We know it's quadratic. It's left 3. Have everything finished here. The last thing we have to do is finish the graph. So we always have to use a table there for quadratics. You cannot use the slope. The vertex is at -3, 0. We already have that graphed. And then standard protocol when we're doing domain restricted graphing or piecewise graphing is you need to plug in that restriction as your next value. So we're going to plug in -2, that's the restricted value, into the equation. So that's -2 plus 3 squared. -2 plus 3 is +1. +1 squared is +1. Giving us the point -2, 1, which we can graph. So -2, 1, that puts us on the restriction, which is perfect. Always put that as a real nice big open point. We check it's supposed to be open, so don't fill it in. And this is quadratic, right? It's a U, which means this is the right side. The left side looks the same, up 1, left 1. That's what our left side looks like. Now there's something that I did wrong. The right side we should not have extended past the restriction. We're only going to the left, so we just need to make sure you stop it at that restriction there. Now you have your domain restricted graph. Okay, for the second piece, let me write that out. F of x equals absolute value of x minus 1 if x is greater than -2. Right, so how I read it, and what's the most obvious thing to look at is those absolute values. You know it's a v. Step 1 is done. Step 2 is look at what the translation is. This -1 is on the outside, not attached to the x. That's telling us to go down 1. So from 0, 0, we're going to go down 1. Put the point, that's your vertex. That's either the top or the bottom of your v for this absolute value graph. Before we finish this off, let's just see what the restriction is telling us. In this case, it's telling us to go greater than -2, so that means we're going to the right of -2, which is good, we're on the right side. And then because it's just greater than, it doesn't have the or equal to, when we get to the restriction, make sure it's open. And other than that, absolute values are really nice because they're linear. We can use the slope. The slope is that number sitting out in front. Since there's nothing sitting out in front, of that absolute value, that doesn't mean your slope is 0, right? That just means your slope is 1. They were just too lazy to write the 1 in front. Your slope is 1 over 1, telling us to rise 1, run 1. Okay, so if we're doing this for a linear absolute value, you go from your vertex up 1, right 1, up 1, right 1. We could do that forever. Just notice it's going to be a straight line going in that direction, but it's a linear absolute value. It's a V. So to make it a V, we go back to the vertex. Now we're going to go up 1, left 1, up 1, left 1. Look at that. They made these graphs connect again. Start with it nice, noticeably, and open. We check. It's supposed to be open, so you leave it that way. And that's what your graph looks like, some kind of wonky looking W, right? That's how I'd write W if I was spelling wonky. Wonky. That's not how you would spell it, but I gotta have a little fun with myself here. That's your piecewise graph done. To finish this off, we need to do domain and range. For domain, it's our x values. The farthest to the left this graph goes, it's an arrow that's saying it goes to negative infinity. That's because it's going to the left. Yes, it's going up, but going up and down is range. We start sliding to the right, and then look what happens. We get to this restriction, and we have an open point for both of them, meaning we have to stop our domain there. We don't have an x value graphed at -2, so we have to stop our domain, open point. That's for that first part of our graph. To finish it off, to save the domain for that blue piece, we have to start it back up at -2, parentheses because it was open, and look what happens. It goes to the right. We hit another arrow saying it goes to positive infinity. Multiple intervals, put a union in between. Domain done. And now let's check out our range. Ranges are y values. The lowest point this reaches is right here, right? That's the lowest piece. That's at -1. It's a filled in point, so we use a bracket. Now we look at how far up does this graph go. We slide up, we slide up. We do have this open point here at 1, but look at along this height of 1, we have filled in points. We have filled in points. We do not have to stop our interval then. So we skip past 1, not having to stop our interval, which is a good thing. I'm trying to erase this, I promise, but there we go. Not stopping our interval at 1, we could go up, and notice it hits those arrows telling us that it's going to go up to positive infinity with the parentheses there. Always parentheses on infinities. But that finishes off domain and range for that wonky piecewise graph. All right, here we go. This is the last one here, piecewise graphing. Again, always just start off by saying what those two pieces are. I chose this last one because it's a little bit interesting, a little more fun in my in my case. But first, let's start with that first piece. That's f of x equals 1/2 x plus 3 if x is less than 0. Okay, we start with it. You look at this, no absolute value, no squared, no exponents at all. So that means this is linear. Linear is nice. We can go quick, right? It's linear. Plus 3 is telling us to go up 3 for our starting point. Go up 3. Put your starting point there. But, oh, hold up. Before I do anything, before I just like slap a nice thick point there, look, got to think ahead sometimes. Your restriction's at 0. Let's go up 3. And instead of putting a big old dark circle, let's put a nice open one. Because we know, you know what, that's going to end up on our restriction. We might have to keep it open. Wink, wink. Okay, so let's look at our restriction now. It's telling us to go where x is less than 0. So we have our restriction at 0, which is why we wrote that as an open point instead of filling it in, because who knows yet. That's 0. It's telling us to graph where x is less than 0, less than meaning we're going to be graphing to the left, so our line should only be on the left side. And then the last piece, because it's just less than, that does mean it's going to be an open point, so good thing we wrote it as a nice big open point instead of filling it in. Okay, so we've already dealt with the restriction. We've actually already put that restricted value point on there. We just need to graph this line to the left. So to finish off a line, for graphing, we use the slope. The slope is 1/2, rise 1, run 2. Again, we're going to the left here. So look what happens. If we use our slope normally, we go up 1 to the right 2, we're on the wrong side, right? We need to be on the left side. So instead of going up 1, right 2, let's go down 1, left 2, same exact slope, same exact line. It's just now we're on the left side. Math's crazy. Math's crazy. Okay, but that gets our linear piece done. Second piece is where it gets interesting, right? For that second piece, we have f of x equals negative x squared if 0 is less than x is less than 2. So, first step, let's look at where is that, what kind of graph is that? It's squared, that means it's quadratic, so it's a u. Specifically, it's negative, so it's a u that should be going upside down like that, or something like that. Obviously, we're going to chunk it up. The second step, where's that vertex going to be? There's nothing added on. Our vertex is 0, 0. No translations. And again, let's think ahead. Our vertex is here at 0, 0. I'm drawing that as a big old open point because we have restrictions at 0. Who knows if we have to fill them in or not. Now we'll finish this graph here. Before we finish the graph, let's look at our restrictions. So again, what this one is telling us is x is between 0 and 2. So we're only going to graph between 0 and 2. Okay, and we can do this, right? We already have a restriction at 0. Let's add the restricted line at 2. So our graph is only going to be in between those two lines. So it's going to be a nice little tiny graph there. At 0, it's just less than, so it's going to be open. And at 2, also it's just the less than, so it's going to be open. So when we get to both of them, they're going to stay open. So that vertex that we graphed as open, keep it open. Don't have to do anything there. To finish off this graph, right, it's quadratic, we have to use the table. And again, start with the vertex, that's at 0, 0. What we do here when we're doing domain restricted graphing, piecewise graphing, is plug in the restrictions. Now we already have one for 0. We don't have to do that again. We need to plug in 2 because that's the other restriction. I'll put plug in 2, that's the restriction. Okay, so we're going to plug in 2 into our equation. Right, our equation is this, negative x squared, so we go negative 2 squared. Again, we have to write it like that because of order of operations. You do the exponent first. 2 squared is 4. That negative sits out in front and we get the point 2, negative 4, which we can graph now. 2, negative 4 puts us right there on the graph on our domain restriction. Again, I'm going to put a nice big open point. We check down here, we keep it open, and that's all we need for our graph. Right, now this is what our quadratic looks like. Here's our vertex at 0, 0. We have this point here on the right hand side. So technically what our u looks like is this, right? If we were to just draw it, something like that. That's the right side, there's the left side. But we're only graphing it in between 0 and 2. So all we're going to have is just this piece of our quadratic. Don't draw any arrows because we have to limit it in between 0 and 2. That's the graph. It's really just a piece there. Okay. Now to finish this off, we're going to do these evaluating, right? This is evaluating functions here. To evaluate them, we can do it either like how we did those first problems, or we could use the graph. And this is a good chance for me to show you all how they're connected. So first, let's look at them. Again, 3 is an x value. We look at which one do we plug it into, and ask yourself, is 3 less than 0? No, it's not. So we don't plug it into the top. And then we get down here. Is 3 in between 0 and 2? And again, wait, hold on. No, it's not. Right, we got 0, we got 2. No, yeah, 3 is not in between. 3 is not less than 0, so we don't plug it into either. Huh? That's strange, right? Let's look at our graph, right? This is just an x value, right? 1, 2, yeah, we're out here. That's because that's outside of our restrictions. Our graph doesn't go to 3. We can't have a value for that. So in this case, there's no solution, right? I'm going to put not in either restriction. Okay, so that happens sometimes. Just make sure you check. All right, now let's plug in the next one. Let's check out 1. So we look at 1, right? Hopefully this one works. We check this first one. Is 1 less than 0? No, right? 1's right here on our number line. That's greater than 0, so we don't plug it into the top one. Is 1 in between 0 and 2? Yeah, it is. So we are going to plug it into the second one. We should actually get a value here. So if we plug in 1 for x into that second one, it looks like this. Negative 1 squared, negative 1 squared, or 1 squared is 1 with the negative out in front gives us negative 1. So we get f of 1 equals negative 1. Or the other way you could write it is as a coordinate point. And why I'm telling you all to write it as a coordinate point is look at, if we go to 1, negative 1, isn't it that point right there, which is on our graph? So it's just showing us that's where our graph is when we plug in 1 for x, which is why we can't have a point for 3, because 3 is way out here. How the heck could we have a point if we didn't graph there? Okay? And then finish this off. I'm having too much fun here with that kind of stuff. We're going to plug in negative 2 for x. Again, figuring out which one we plug it into. So we ask, is negative 2 less than 0? Yeah, it is, because look at negative 2 is over here. It's to the left of 0. So we do plug it in there into that first one. We don't plug it in the second one because this is saying negative 2 is in between 0 and 2. That's not right. So we don't plug it into the second one. Plug it into the first one. It works there. So we will have 1/2 negative 2 plus 3. Now let me take that down here. I know we're running out of room. F of negative 2, 1/2 negative 2 plus 3. 1/2 of negative 2. You just have to think of what's half of 2. Half of 2 is 1. Negative times a positive is negative. So half of negative 2 is negative 1 plus 3. Negative 1 plus 3 is positive 2, giving us the point, giving us f of negative 2 equals 2. Or again, we could write that as a coordinate point of negative 2, 2. And look at that. Look what happens. Let's go to negative 2, 2 on our graph. Negative 2 up 2. We already have a point there, right? So that's showing us that we could either choose to plug it into these tables and these values if we have the graph. If you don't have the graph, plug it in. If you do have the graph, then when it's saying f of negative 2, just go to negative 2 on x, which is right there. Your graph's up 1, 2. We could have just went, oh, it's going to be 2 without plugging it in. That's just kind of connecting that question into what we're going to see a little bit later on. But hopefully that helps you out with y'all's homework. Hopefully, if you have any more questions, you email me.